Um, hey guys, so welcome to today's stream, and today, yes, I'm live. So, without very further ado, let's just dive right into it. So, promises are actually very important, and um, this is something that any developer that is using JavaScript should focus on very heavily, and like try to like it will be good if you remember more of the promise APIs or the promise methods, so and how it works. So it's a good thing to learn. So promise is an object representing an eventual completion or failure of an asynchronous operation. So how JavaScript works is that JavaScript, as we know that it's a single-threaded language, but what promises allows us is that using the microtask task, like it's just a terminology to remember. We are not going that deeper into learning what microtasks are. But what Promises does basically, it uses a browser thread, so a thread of the browser, and their JavaScript code is done. So this is the main thread. So our browser produces another thread, and that there another JavaScript code is done. And on the completion of that or failure of that task, the thread again comes back to the main thread. So that's how promises basically work in just a very basic sense. Essentially, a promise is a return object to which you attach callbacks instead of passing callbacks into a function. Imagine a function create audio files async, which asynchronously generates a sound file given a configuration record and two callbacks function. You call one call if the audio file is once called if the audio file is successfully created, and the other called if an error occurs. Has some uses of create audio file async. So success callback result console log failure callback, and then we um, basically these are two callbacks that should be passed when this promise uh, fails or success, and this is the audio file async function where which takes audio settings, and it execute this method in future after this create audio file async has failed or succeeded. So that's how promises work. Guarantees. Unlike old-fashioned past and callback, our promises come with some guarantees. So why do we need promises? Because before promises, there was developers did use asynchronous code, because obviously you need to fetch something from the database, and for that you can't just block uh, the main thread. So you need to do stuff that off the main thread. You want that stuff to come back again to the thread. So for that, callbacks were used. So what they did was that um, uh, in the asynchronous functions, when once they were completed, then after that callbacks were called and callbacks were passed in to the function. And so callbacks are basically functions that are passed into another function and then called later on. So that's how they work. So callbacks added with then will never be invoked before completion or current uh, of the current run of JavaScript event loop. These callbacks will be involved. So yeah, so before completion. So uh, let's see what they mean by this. Uh, the, okay, so we'll come back to event loop because event loop is a topic in the advanced section. Callbacks are added with then will never be invoked before completion of current run of JavaScript event loop. So um, let's say we make a function. Let's say we add a while loop, a while one, and we run that. So these callbacks will never be called because JavaScript event loop will run like continuously and uh, at that stage. So that's what they are saying. So that these callbacks will never be called. These callbacks will be invoked even if they are added after success of, or like let's say we don't have a while loop, we have millions of lines of code, and that would be a problem. These callbacks will be invoked even if they are added after the success or failure of asynchronous operations that the promise is given. Multiple callbacks may be added by calling them several times. They will be invoked after another in order in which they are inserted. Yeah. So first thing, that's a guarantee that callbacks added will not never be invoked before the completion of the current run of the event loop, because so like these callbacks will not be invoked before like the function is complete. These callbacks will never be invoked if they are added after success or failure of asynchronous of. So these callbacks will be, that's a very like, these callbacks will be invoked even if they were added after the success or failure of the asynchronous operation that the promise represents. Multiple callbacks may be added by calling dot then dot then dot then. So you can change that and add multiple callbacks like this, like dot then, and then you can add dot then again. So to make another callback. So common need to execute two or more asynchronous operation back to back, where each subsequent operation starts with previous operation succeeds with the results of previous step. We accomplish this by creating promise chain. Yep. So here's the magic. The then function returns a new promise different from original. So promise is supposed to do something. Then promise 2 is equals to promise dot then uh, success callback, comma failure callback. So uh, here's the magic. The then function returns a new promise different from the original. Yep. Promise 2 is equals to do something dot then we'll call the success callback. If not, then the failure callback. This second promise, promise to represent the compilation, not just do something, but also the success callback or failure callback. You pass them, and which can be other asynchronous function returning a promise. When that's the case, any callback added to promise 2 will get queued behind the promise returned by either a success or failure callback. Basically, each promise represents the completion of another asynchronous step in the chain. In old days, doing several asynchronous operations in row would lead to more classic callback pyramid of doom. So this is also called callback hell. So what happened earlier, where do something and then a function, which is where we pass in a function which take like result, and then we did then we so result do something pass in the function. uh, this is the upper level function. So when so this ends here, and this ends here, this ends here. So do third time new. So like in the old callback version, we had to write such big code to uh, like for resolving asynchronous calls in modern function, we attach a callbacks and return promise instead of forming promise. So now we can easily do stuff like this. So um so they should also have define do something, so it would be have been easier to understand. So basically they are calling do something with a function, so which is a callback function which will be called inside something. So this is not the do something function, it's the calling of that do something function. So and then inside that do something thing else, inside that function there's another function called do something else, which takes the result, and then it also has a callback. And then there's also a third function which also has a callback, and which console logs got the final results. So that's like very hard to understand, very unreadable. But then promises came, and can use dot then and easily return the values of these function by just not calling them by a callback, but calling them like this. And we can also catch the errors in just one line rather than passing failure callback in every like function. So you need to catch only once. So errors are you need to catch the errors only one, and that's also a good thing. Where uh, for the whole task, you can catch error only once, and that works. So to something dot then result. So it's the arrow function notation of the same function, and always return result, otherwise callbacks won't catch the result on a previous one. So yes, so the result should be returned. This may be one of if the problem last and and have called earlier. Yep. So here there is no return. So before even like this completing through, this will be called, and that will make a problem. Uh, because we haven't returned this fetch. So then URL fetch. So yeah, so they are using the arrow notation. So that's why they are not explicitly writing return, but the return basically this is like in let me just show you. We have talked about arrow function, but yeah, it's just better if someone's not understanding this, because it mm, arrow functions are actually not very readable in my opinion. But if you don't know them, so these both codes are the same code. So yep. So basically, you can write it in this way, or you can just omit the return, and this will always be returned if you are not adding them into a block scope. So that's what arrow function does. So we have talked about curly braces, how they if you are you like everything, every loop, everything allows you to write just only one statement. But what block does, it allows you to um, combine a group of statements into one single statement. So that's how we see it. And like let's say for loop, and normally what's happening if we uh, want this to, like, obviously array is not defined, index is not like array is not defined, so but normally mm, what is happening, like if you write a second line, let's say const a equals to 7. So now what's happening, this for loop is running from 0 to array dot length, and only this line is being executed. If you want these two lines to be executed on every loop iteration, then we have to use these square brackets. And so with these we can with this, what we are doing, we are grouping these both statements into one statement. So that's how we see like curly braces. I just want to check what error was this. Okay, fast expression. Oh, cool. Okay. Yep. So Uh, but so what other function does is that if you are writing just one statement, then that statement is just return. But if you are writing a block arc, then you have to tell what you want to return if you want to return something. Chaining after a cache. It is possible to chain a failure, i.e., a catch, when is useful to accomplish new action even after action failed in the chain. Read the following summary. Yep. So sometimes, let's say you have an error, but after the error you want to refetch or do something, and so for that you can change stuff after the catch block, and you can use the error to, like, let's say you have three backup APIs and you want to call that. I don't know why anybody would have that, but probably there's an architecture somewhere where someone wants that infrastructure where they have three API URLs. So then they could check in for the first. If they find an error, they can check in the second. Though it's not very ideal, but yeah, that could be done. So by using then after the catch, the propagation. So yeah, so as we talked that we need to only use the catch in one time, and then you can use it multiple times. It's not a problem, but yeah, it's okay if you catch error from the first time. Cons do something, think, do something else. If there is an exception, the browser will look down the chain for catch handler on the record. So yeah, so what they are saying that try catch block, they are telling us that this could also be done in catch block, and this is and another syntax, totally completely different syntax. I know this that's why I can easily understand this, but it's actually not very well written. I'm a little frustrated with the way they have just they were doing everything in then, and then they came to async of it, and it's just icky that mm, but yeah, so just forget this. So this is, so there was a old syntax that used callbacks, then there came a newer syntax that used dot then and catch and work like this. There came one another syntax that is also a syntactical sugar on .NET, where now you can easily uh, write it like this. So const result is equal to you have to write await here. So await signifies that like in the function, uh, they haven't written async also. So they have written async. Yeah. So in the function start you have to write async, and then you have to you can declare the function, and you declare a try block, which signifies the things you want to do. So basically, what the things in the dot then blocks, and then you can easily make variables. So const result is equals to await. So await means that when do something is completed, till the time do something is completed, don't run these functions or these statements. And once it's completed, then the is the value will become uh, like be put in result. Then this will work, then this will work. If there's a error in any of one of this, then the cache one will block will be activated. So this is the latest syntax for promises, and it's basically a syntactical sugar where, like yesterday we talked about syntactical sugar, where JavaScript wants things to be much more easier and provide a modern way of doing stuff. But there are also like older ways to do it. And they do work. They provide to solve the problem. So what JavaScript does is just build on top of it, and provide a different syntax that you can use, the which uh, basically does the same thing. It builds on promises. For example, this one, it's the same function as before. You can read more about syntax here. Yep, promises, rejection events, deletion, and yep. So, rejection handler is sent when a promise is rejected after the rejection has been handled by the executor's reject function. Unhandler rejection sent when promise is rejected, but no rejection handlers available in both cases. So, then you can on the process you can add these events. So, uh, this is a node thing. So, you include your projects, you have another, and so on unhandled rejections, you can add an event, and then you can add codes to handle them. So it's just better to add a catch block, because no, I don't actually see this in a lot of code, but probably you might have some use cases where this is required. For Node.js, to prevent error from being logged on the console, the default action that would otherwise occur, adding the process on listener is not necessary. There's no need for an equivalent of the browser runtime to run the formula. So if you add that provision but don't have code within the handle version, then it drops on the floor as an email. So ideally you should add code with the examine each rejected province and make sure it was not caused by actual code bug. Exactly. So add the catch block, basically. Creating a promise around an old callback event. A promise can be created from scratch using its constructor. This should be needed only to wrap an old API. Yep. So what they are trying to basically do is right now make a bridge between the callback system and the promiser system. So that if someone wants to migrate their code, they can do this. I don't think this is very important to learn, because no new code might be using callback to handle asynchronous code, and like you never will never need to write it. But let's just go into it. If you came across a legacy code that you want, like you would want to like make it modern, then it will be helpful. But I guess that's the time when you come back to this article, and actually uh, at what time you are doing it will make more sense that you uh, do it from here. So let's just briefly go through it. An ideal or synchronous should return promises. Unfortunately, some API expect success or failure callbacks to be passed in the old way. Most set time on the most obvious. Yeah, so I get what they're saying. So, JavaScript also has some functions like set timeout that use wants callbacks, like in the old way, mixing old style callbacks and promises problematic. If say something fails to contain a programming error, nothing catches it. Set timeout is here to blame. Yep. So luckily, we can wrap set timers and a promise, but best practice is to wrap problematic function at the lowest possible level and never call them directly. So const wait is equals to ms is equals to new promise resolve set set timeout resolve ms. Okay. So wait uh, and we pass in the millisecond dot 10 uh, we pass in the function and we catch and we do the so what's happening we call in the wait function. So what wait will return a new promise. Wait will return a new promise with with of um a set timeout. So, and that promise will take a variable which will be resolved, and we then add the dot then, and we add the method to be resolved, and that method is this, and um, and that's how it works. Basically, the promise constructor takes execute a function and lets us resolve the and reject promise manually. Since set timers doesn't really fail, we left out the reject case. Yeah. Composition. Promise.resolve, promise.reject are shortcuts to manually create already resolved rejected promise respectively. These can be useful on time. Promise.all, promise.trace are two composition tools for running asynchronous operations in parallel. We can start operations in parallel and wait for them all to finish like this. Promise.all. So what promises.all does, it runs all these functions in parallel, and then we can get their results, and we can do stuff. I hope they go deeper into this. It is important to note that one of the promise in the array promise all will throw an error and abort the operation. This may cause unexpected state or behavior. Promise.all settled is another composition tool that ensures all operations are complete before resolving. Sequential composition is possible using clever JavaScript. Okay, so it is more than if one of the promises in the array rejects promise dot all will throw the error and abort other operations. So yeah, so if any one of the objects is like let's say you call four APIs and on the and three went through but one didn't. So that will go into the catch block. This may cause unexpected state or behavior. Promise.all settle is another composition tool that ensures all operations are complete before resolving. So yep. Uh, in the references section. We come to another composition tool that ensures all operations are complete before resolving. Possible. Func1, func2, func3 dot reduce. We that's P is the accumulator, F is the dot then function, P dot then F promise dot resolve. Then basically we reduce the array of asynchronous function down to a promise string. This code is equivalent to promise dot resolve dot then func1 dot then func2. Yep. This can be made into reusable compose function, which is common in functional programming. So apply async is equals to uh, acc comma val hello acc dot then compose async is also function. This is going above my head actually. Uh, The compose async function will accept any number of functions as arguments and will return a new function that accepts the initial value to be passed through the composition pipeline. So apply async will take functions. Okay, cool. Yeah. Basically, they are doing this same thing. And provide surprising function passed to then will never be called synchronously, even when are already resolved promises. Promise the resolve dot then console log 2, console log 1. So it will print out 1 and 2. Yep. So this is related to event loop. So like this goes into the microservice stack and then it comes back in. Instead of running immediately, the pass function is put into a microtask queue, which means it runs later only after the function which created it exists and when JavaScript execution stack is empty, just before control is returned to the event loop. Pretty soon. Yeah, it's actually pretty soon, but not that soon. Yeah, so they have the same operation. Um, so console log one will be done, so that's how one comes. Um, wait, 0.10. Okay, so this is actually a event loop concept, but obviously promises are very related to event loop, so I understand why they have dealt into this. And so what happens is first, uh, let me just make a diagram. I guess that will be helpful. Uh, Excel, draw, Excel lab draw. Yeah, so it the first thing it does is a function called wait. So that's done. Then with returns a new promise, and then it calls in wait zero. So um, okay, so let's make something. I should have just used the square, I guess, the rectangle. So this is our queue, and uh, so this is our micro task queue. So let's make two queues actually. So there's also one another queue also, but currently for this example, we are focusing on tasks and Microsoft tasks only. So what happens is that now wait zero will go to the microtask queue. So uh, shouldn't it be 1423? Instead of running immediately, the pass function is put in the micro which runs, you know. So how does this work? I get why this will be first from my previous knowledge. Um, but this is confusing for because from my previous knowledge, there's no explanation about it in here. So uh, that's of no help, and it's just very irritating that uh, because for, from what I know, like a little bit, uh, for like how stuff works. So for me, I would like if I was in an interview, someone gave me this code, I would have written 1423, and that's the problem. Okay. I think I have got some. Hmm. Uh, because actually, like set timer does not set time out. Set, okay, yeah. Set timer goes into the task queue. So what will happen? Okay, cool. So yep. So we'll have to make another queue also. So yep. Um. So the main thread is working, and it registers this function. It registers this set wait zero, so which gives us a new a promise, and um, so that promise should go in the microtask queue. So let's just name them. How do I name them? I haven't used this in a while. I guess this should, nope, doesn't. I know there was something to write, so isn't there? I hope there is. Yep, this. So my, huh. Okay, this is color. We could have changed the color. Let's make it blue. Micro task. So all task. Task. Uh, okay, so this is what's happening. Okay, so this weight zero is called. So it comes like it is a new promise. So it comes into the task queue. Um, so I I should go into medium. This is difficult. Okay, so yep. Um, weight zero comes here first. Uh, as it's a new microtask, it's a new promise. Then promise the resolve comes here. Promise the resolve comes here. Then it console logs one. Yes. So it console logs one. Then this now it comes like as the main thread is empty, it comes to the microtask queue and it resolves weight zero. So now weight zero will be transferred to the task queue because there's a set timeout function. And though it is zero, like set timeout is zero, but like actually zero in set timeout actually does not mean zero. It says 0.0 something seconds. And what happens is that once the microtask queue uh, starts finishing, then it goes completing till the end. So uh, that's what happens. So wait will come here, promise dot resolve will come here, and then 2 and 3 will be printed, well, and then after 2 and 3 is printed, this will get out. Wait will come back again here. Um, will it? No, no, no. Yeah. So uh, so wait will be resolved. So after resolving, it will still be here, but it will get completed. So that's how we get the output. One, uh, two, four. Yep. So it's clear. I don't know, like if a lot of people got to understand this. I'm sure, like reading more about event loop in the advanced section will make more sense. What I'm talking about, but it is actually very difficult. Experienced develop. I've seen experienced developers not doing very great with in this, and thus it is actually very difficult. Promise callbacks are handled at microservices handled as task queues. Yeah, exactly what I told. So, new promise. What's the name? Excalidraw. I saw some other uh, streamer using this, and it's actually very good. He has this whole plan of like drop plus. I don't use that. I don't have enough money for that. But yeah. So new promise is also new promise function resolve reject console.log promise callback resolve then a function result console log promise callback dot done set timeout. So how will this work? Let's just try once for ourselves and then we'll see. So the set promise will go into the microtask queue. Um, so and the set timeout will go into the task queue. So what will happen? Uh, so from the main thread, actually we don't need this. Uh, from the main thread, it will console log promise pending. Comma undefined. No, no. It has the value of the promise which is not resolved. So promise. We'll check this out. I'm not very sure if I'll do it correct, but you also can try with me if you got a bit of understanding. So it will undefined, like promise object. Sorry, promise obj. I'll just draw. So that will be the first line. What will be next? So now the microtask. We'll go to the microtask queue because. No, no, no. So um, till now, if we go in the task queue, let's see. Uh, promise call. Huh? Call not function. Okay, okay, okay. So after resolving this, will go in the task queue. So that's why promise pending. We are getting promise pending from here, and then it's calling this, basically this calling this, and then fulfill. It's very difficult. We'll come to know about these in the advanced section. Um, it's actually I'm not sure they should have gone in this much deep. I thought they will go into promises dot all, promise dot all settled and all that, and they'll go much deeper into promises, methods of promises, but and how can these be used when we are using asynchronous calls. But they want to go into event loop, and that's also a part of like okay, but it would have been better. So they are talking about nesting of promises. You don't actually need to nest. Uh, Nesting control structure is a limited scope and catch segment, especially nested catch only catches failures in the scope alone, not higher ups. Yep. No. So you can actually not nest and actually use dot then and it's okay. So it works in that way also. So let's and return the values from each then so that will also work. You'll find a very less cases. I don't think you'll find any to message or not then. Okay. Common mistakes. No. Forgot to return. Don't forget to return. Forgot to terminate chain. Always add the catch. Turn the promise. If you run in the session in which you have the promise task such as event for callback, the file this follow event benefit in my class it checks status balance. If you think microtask may help solve this problem, see the microtask guide to learn. If you run into a situation in which you have promises and tasks, such as events or callbacks, which is firing in unpredicted order, it is possible you may benefit from using a microtask to check status or balance out your promises when promises are created conditionally. Yeah. Um, this was actually very mind draining. Um, I hope you got like I, I got some bit of more information. Um, though I would have preferred if they explained a promise or all set up much more well, and they left out the event loop stuff for the advanced section only, where they I know they like obviously it seems like they are discussing the event loop, and obviously they will have to do it properly. But yeah, so tomorrow we'll go with the iterators and generators, which is not a topic that is used a lot. It's good to know. It does a few stuff. I haven't seen a lot of developers using um, iterators and generators, but yeah, I'm also quite in my learning phase, and um, so let's see what uh, we we are at a stage where we have to learn everything and like get to know. So